Welcome to your class. Today we are going to be looking at segment, and we are going to use combined applications where we are going to use arc length and sector area to work out our problems. Okay, so this is a important topic in trigonometry. Okay, so we're going to look at. Okay, so the objectives of this lesson is to make sure by the end of it you're going to understand what is a segment and calculate the area of it. Okay, so we're going to understand what is a segment and calculate its area. Okay, so we're going to derive the formula to find the area of a segment. Okay, so we have the formulas we already have. We're going to use that to calculate the area of a segment. Okay, so the other thing is you're going to apply arc length, sector area, and segment area formulas. Okay, we already derived these formulas. Okay, so you can watch them and see how do we derive it and how do we use them. Okay, then now we are adding on to use segment area formulas. Okay, so using all these formula in, we are going to solve compound problems. Okay, we have an exam problem, exam sample problem. We are going to be solving it step by step and showing you how to use this. Okay, so you can watch this the video of this arc length and sector area, then come and watch this one. Let's start by deriving the area of a segment. Okay, so we want to know how can you find the area of a segment. Okay, so firstly, before we go, let's say understand what is a segment. Okay, so given a circle like this, we have this one, this half, we call it a sector. Okay, this one is a sector. Okay, so if we draw a straight line from here to here, okay, if we draw a straight line from here to here, okay, let's say this angle at the center is theta. As always, it's a common angle. Okay, so if we draw a straight line from here, let's say this is A, this is B, and this is our center O. Okay, so if we draw a straight line from A and B, this is our sector. Okay, from our sector, this area which is surrounded by the arc AB and the straight line AB is what we call a segment. Okay, is what we call a segment. Okay, so when you are told what is a segment, you just know that it's an area which is bounded by an arc and a straight line of the same points. Okay, so this is the simple way of saying a segment. Okay, so let's see how do we find this area. Okay, so let's start with what we already know. We already know that the area of this whole sector, okay, the area of this whole sector, area of a sector is equals to half r squared theta. Okay, so we derived this in the previous video. Okay, so you can go and watch it. Okay, then the next thing is we are going to see that to find the area of this OAB triangle, we are going to need a sine rule. Okay, here we have our radius r and r. We are going to need sine rule. Okay, this sine rule we use it to find area. Okay, so the area of this triangle, area of triangle is given by half r times r. A, this is OA, this side, right? And OA this side, and OB this side. Okay, so we're going to see that it's r times r. Okay, sine theta. Okay, this is theta angle. Okay, so if you know how to use sine rule, if you don't know, you can find a video which is something to do with this and know how to use sine rule. Okay, so we want to find the area of A, B, O. Okay, OAB, this one. Okay, this area of this triangle, we use this formula. Okay, so now to find the area of this segment, the only thing we have to do is we just have to take the area of this sector, the area of this whole sector, which is this one, and subtract the area of this segment. Okay, so this means that we're going to say area of segment is equals to, we're going to take the area of the sector, which is half r squared theta, then we subtract this one, which is half r squared. You see, if we multiply r by r, it becomes r squared sine theta. Okay, so this means that if we factor out half r squared, it's going to be theta minus sine theta. Okay, so this is the easy way of doing it. Okay, so this is going to be our area of a segment. Okay, so make sure you remember this formula, the previous formula of arc length. I keep on reminding arc length, r theta. Okay, so these are the three most important topics in this trigonometry area where we deal with circles. Okay, so this is the first thing, and this is the second one, and this is the third one. Okay, So we're going to remember this. This is the area of a segment, and this is the area of a sector, and this is the arc length. Okay, so we're going to be using this. Okay, so let's see how do we apply this in a question. On our practice question here, now we can say that we have a question here, which was from another question paper. Okay, so let's take a look at it. Okay, the diagram above shows the plan of a portio. Okay, so this is a portio. Okay, portio is where people sit. Okay, so the portio PQRS is in a shape of a sector of a circle with center Q. Okay, so this is the center. Okay, and radius r. Okay, you can see that this radius r is 6 centimeters. Okay, then given that the length of the line PR, this line is equals to 6 root 3 meters. Okay, so 6 root 3 meters, this is the length. Okay, find in meters squared to 1 decimal places the area of the segment PRS. Okay, so as we should find the area of this segment. Okay, so this is our duty. Okay, we learned how to find it, and now we are going to apply it how to find it. Okay, find in meters to 1 decimal places the perimeter of the portion PQRS. Okay, so we are going to find the perimeter of this or the whole portion from PQRS then back to P. Okay, so the first step is we just have to make sure we know our formula, but it requires this angle. Okay, so this means that we are going to find this angle. Okay, so we'll see how to find this angle. Okay, so let's start by finding this angle. Then we find the area of the segment and continue the question. Let's solve our question, which just that find in meters squared to 1 decimal place the area of the segment PRS. Okay, so let's bring our diagram and see. Okay, here we are supposed to find this the area of this segment. So this is the segment we are supposed to find. Okay, so the first thing we know that our area of a segment, our area is given by half r squared theta minus sine theta. Okay, so this is our area. Okay, so what we are going to do is we have to find this theta. We already have our r, which is radius, but we don't have our theta. Okay, so we're going to use cosine rule to find this theta. Okay, so how do we do that? Given this one, we just have to you can check how do we find the side with the cosine rule, because I'm going to do it fast here. Okay, so what do we do is we just take this side and say and square it, which is 6 root 3 squared. Okay, is equals to then 6 squared plus 6 squared, then minus, and then you take this side 6 times again 6, this side 6. Okay, cos theta. Okay, so this you did. You just take this side and square it, this side, then take this side, square it, plus this side squared, minus this side times this side, cos theta. Okay, this is how we do it. Okay, now let's see. Here, you just have to put 2 here. I forgot 2. You put 2 here, it becomes 2 times this one. Okay, so here you can see that our answer becomes 36 times 3. And here it becomes 36 plus 36, which is 72. Okay, then it becomes 6 times 6, 36 times 2, which is 72 cos theta. Okay, so what we are going to do is we're going to take this and put it this side. It becomes 72 cos theta is equals to 72 minus 36 times 3. Let's just put it like this, 36 times 3. Okay, we just punch it on the calculator. Okay, so cos theta is equals to 72. Okay, 72 minus, here you can see that, okay, you can see here the answer is 108. Okay, so over 72. Okay, so this means that we are going to get a cos theta is equals to 36 minus 36 over 72, which is going to give us a minus half. Okay, so if we say arc cos half, okay, arc cos half, okay, we are going to get 2 pi over 3. Okay, make sure when you punch this arc cos half minus half, you are going to use your calculator in rads. Okay, so make sure when you whenever you use rads, you're going to use rads. Okay, so you're going to give 2 pi over theta rads. Okay, is our angle. Okay, so this is how we get our angle. We just use the cosine rule and solve this angle. After solving this angle, now we just have to use this formula to find the area. Okay, we already have our radius. We have found our area, our theta. Now we just have to find we just have to find the area. Okay, so we can also area is equals to half r squared is 6 times 6, which is 36. Okay, then we say times theta. Our theta here is going to be 2 pi over 3 minus sine 2 pi over 3. Okay, so punching this one calculator, we're going to get our area as 22.11. Okay, so this is going to be our area. Since it's to one decimal place, it's going to be 22.1. Okay, meter squared. Okay, so this is going to be our answer. Okay, so this was that for this question. Let's see how to solve the next one. Our next question is requiring us to find in meters to one decimal place the perimeter of the portion PQRS. Okay, so let's bring our shape here. We are supposed to find the perimeter of all this portion. Okay, this one. Okay, so the first thing we're going to do is we're going to substitute our angle. We've found that this angle is to be 2 pi over 3 radians. Okay, okay, so this is going to be our answer. Okay, so now we just have to find the perimeter. Okay, so now we know that PQ, so our perimeter is going to be PQ, is going to be PQ plus QR plus arc RP. Okay, so this is our arc. Okay, so now you can see that PQ is 6 plus QR is 6. Okay, what we have to find is arc RP. Okay, so let's find arc RP. Okay, so how do we find the area of the arc? Okay, we already know that we just have to use the formula r theta. Okay, so this is the formula for an arc length. Okay, so we here we have our radius and our length. Okay, so it's very easy. Okay, so I'm just going to say our radius is 6 meters times our angle is 2 pi over 3. Okay, so this our angle is in radian, so it's very easy. Okay, so you can say 3 into 1, then is 2 here. Okay, so now we can say 2 times 2 pi, it becomes 4 pi. Okay, so this is going to be the arc. Okay, so now to find the perimeter of the whole portion, we're going to say 6 plus 6 plus 4 pi. Okay, so we just have to punch this on calculator and find our answer. Our answer becomes to one decimal place, it becomes 24.6. Okay, so 24.6 meters is going to be the length of our portion. Okay, so this is how we solve it. The first thing you just have to find which perimeter we're talking about. 6 plus 6 plus 6. Okay, now we see that we need to find this arc length, and we're going to use this formula. Then we found this formula. Now we just have to add this and around to one decimal place as said. Okay, so this was that. Okay, so this was our segment and combined problems. Okay, so we used problems from segments and arc length and sector. Okay, so you combined it and find our and solved our problem here. Okay, so this was that. Make sure you subscribe so that you won't miss the next chapters and you won't miss the next concept. Okay.